I wanted to do this homework example from the section on correlation using the calculator. So it gives me, says, listed below are numbers, blah, blah, blah. Construct a scatter plot, find the linear correlation coefficient R and the p-value of R. Determine whether there's sufficient evidence to support a claim of linear correlation with a significance of 0.01. So here are the data. So first, let's construct the scatter plot. So on the calculator, we can do that. And what I'm going to do is enter these numbers. The first numbers I'm going to enter into list 1, the x values. The y values I'm going to enter into list 2. I'm going to do that first by hitting stat, and then I'm going to clear out whatever I might have in list 1 and list 2 by going to clear list, and then second list 1, which is right above the number 1, comma, second list 2, and then when I hit enter, done. So those lists are clear, and now I can enter the data into those lists by going stat, edit, which is the first thing, and there's, well, list 3 has something, but we're not going to use list 3, so it doesn't matter. So in list 1, I'm entering the first list of numbers, which I copied down, 79.9, 81.0, I'll just enter 81 for that, 56.9, 66.3, 78.2, 38.9. Okay, those are the x values. And then for the y values, I'll arrow over. For list 2, it's 5.4. And then it's 9.3. And then it's 3.3. And then it's 1.8. And then it's 11.1. And then 0.1. Okay, when you're entering a bunch of numbers, I'm just going to double check to make sure I didn't make a mistake in entering these numbers, which will mess the whole thing up. Looks okay. So to make the scatter plot first, I'm going to go to this, I'm going to do what's called a stat plot. So to get there, let me get out of here, second quit. And to do the stat plot, you see it's above the y equals thing. So I'm going to go second y equals, and that gives me to the stat plot menu. And notice I have stat plots number 1, the plot is on, and you want your stat plot number 1 to look like this. Enter. Let me enter here. So you want it on. There's a choice of types. I think you want the first type. These other types are other things like a box and whisker plot. We don't want to do those. The x values, where the x list is L1, the y list is L2. These are the little marks. We're going to get little squares out of this. Okay, the color doesn't matter now. So that's the way you want it set up. Make sure yours is set up that way. So if I quit, okay, and now go to the y equals menu. Well, let me clear that out, because I don't want to graph that equation that was in there. But notice that plot 1, you see how it's highlighted? That means the plot is turned on. Once you have it set up properly, if you arrow up there, which I just did, and hit enter, that's a toggle to turn it off. See, I get out of there, it's off. If I go up there again and hit enter, that's a toggle, and now it's on. So you want to make sure it's on. And to get the scatter plot, I'm going to go to zoom, and I'm going to go to zoom stat, which looks like it's number 9 here. And if I go to zoom stat, there's a picture, a scatter plot of this picture. Now let's see which one of the questions, which one of the answers in the homework looks like that. So let me go back to the homework question. So which one of these scatter plots look like the one on the graph? So let's look at these again. I think it's D, but let's look at the graph again. Yeah, I think that one looks like choice D here. So I'm going to go for choice D, check answer. Well done. Okay. Now the next part, the linear correlation coefficient R, We're going to do this by doing what's called a ln-reg t-test on the calculator. So now on the calculator, I'm going back to Stat, Tests, and down near the bottom is something called ln-reg t-test. You have to arrow down a bit. There it is. See, there's ln-reg t-test, ln-reg t-int, but we want ln-reg t-test. There's that. And the X values are in list 1, so if that's not in L1 there already, put it in there. The Y values are in list 2. If you don't have list 2 entered there, enter list 2 there. The frequency is going to be 1. For this hypothesis test, the beta and rho not equals 0, and that not equals 0 is the form of the alternate hypothesis. Just as a comment, the null hypothesis is rho is equal to 0, not coming from the original claim. They're all going to be like that, and the rho not equals 0 is the alternate hypothesis. L2, that is correct. That is, now here you can store the regression equation in Y1. Now there's no reason to do that for this homework, so I'm going to clear that out. But if you wanted to store it, let me just show you how to put that back in there. If you hit vars, and then yvars, and then function, and then the first thing there is y1, that'll put that there. If you wanted to store the regression equation in the yvars here in the graphing part of the calculator. I don't think this homework asks us for that to graph this particular equation, so I'm going to clear that out, that particular one. And now, when I hit calculate, I'll get a bunch of numbers. Now here are the important numbers here. That T, I'm going to write these down, that's the test statistic, 2.790742068. They'll probably ask for a rounded off thing. And that P, which is the p-value, 0.04927470049. The A and the B are the coefficients of the regression equation. Maybe I'll write those down. I don't know if they ask for that. The A is negative 8.930777184. The B is 0.2108291702. That's the regression equation. Notice it says y equals a plus bx. So the regression equation, which is sort of the line of best fit for these data, is y equals negative 8.9 plus 0.21x. To be honest, I'm not sure what that s thing is, but the other important thing here is this r. That's the correlation coefficient. The r, which I'm definitely writing down, and I'm sure they're going to ask for, is 0.812821515. So I wrote down that information, and let's see how to answer the rest of these questions. So the linear correlation coefficient R, that's that R value, to 3 decimal places, 0.813, 0.813. Okay, that's good. Next part, the null and alternate hypothesis. As I said, the null hypothesis is always rho is equal to 0, and the alternate hypothesis is always going to be rho is not equal to 0. And by the way, that null hypothesis is not from the original claim when we have to answer the question about the conclusion. Let's check that. Nice work. The test statistic, that's that T thing that I wrote down. They want 2 decimal places. It was 2.79 to 2 decimal places. 2.79. Fantastic. The p-value that was the usual p-value to 3 decimal places, it was 0.049 to 3 decimal places. 0.049. Nice work. Okay. And because the p-value is, now the p-value is 0.049, the significance was 0.01, so the p-value is bigger than the significance. So it's greater than the significance. That means in terms of the hypothesis test, we fail to reject H null, which was not from the original claim. So just looking at the hypothesis says fail to reject H null, not from the original claim. See, fail to reject H null, not from the original. There is not sufficient evidence to support the claim of correlation. So that's the conclusion. There's not sufficient evidence to support the claim of correlation. Let's see which answer matches with that. There is not sufficient evidence for the claim of correlation. There is not sufficient evidence to support the claim of linear correlation. Nice work.